copy them, so just get a pen.
How are you supposed to do binomials without calculating?
Yeah, true. That's it.
Yeah, same.
I couldn't even think it's
Same
it.
Well,
Well, everyone started.
Right, friends. So, before we start, are you videoing already?
Yeah.
Oh, wow. Okay. Right, so this is non-calculator first, the non-calculator paper and then the calculator paper. Obviously there are a couple of things that you can think, I was only going to turn up on the calculator paper, but you can never be quite sure, so we might as well cover everything. I will skip through things that I don't think are too much of an issue. I will write on here, I'm recording it, so hopefully you can go back and look back over it again. So these are last year's papers, so between the two papers you're going to cover virtually everything. And then paper 1, paper 2.
Have we got the mark scheme?
The mark schemes, I can put them on somewhere.
Cool.
We can sort that, yeah. So we just work through together and we're doing, try and draw out various points, talk generally about each of the topics. You know a lot of it now, it's just GCSE, just make it a bit harder. So we can just go from there really. Okay, and I'm going to write on the board and then fail to know how to sort it out, but we'll work around it. So, this first one is really something you could find on GCSE quite easily. So it's a little bit of a using standard form and then working out a value. So I imagine the first thing we do is probably transform that 2.42 times 10 to the 3 into a real number. Yes. So that's going to be what, 2420? Divided by 20, rooted. That we can do nicely. Zeros cancel. 242 divided by 2, 121. Oh, that's looking good because we know the square root of 121.
11.
Straight away. Look at that. Nice.
Plus minus.
Oh!
No! Oh my gosh!
There's no plus or minus on the thing. So if there's no plus or minus on there, you just need a positive.
Really?
Yeah. So what the difference is,
Oh, okay, but I thought you were right.
Yeah.
if it said x squared is 121, what's x, then it's plus minus. If it's just a square root symbol,
Then you just
after the positive,
Unless
unless it's a plus or minus in front.
Even if it's wrong, I believe that. I'm like,
No? Okay. So, there's your first
If you
one.
put plus minus, would you use
I'll
that?
just move this up now, can't save or cancel?
cancel. That was easy.
Okay. So, moving on. Difference of two squares? We can do that, can't we?
Is that?
Yeah, x plus y times x minus y. Oh, no, I won't bother writing on. So, just x squared minus y squared. There's going to be loads of difference of two squares to spot, not only in further maths, but also normal GCSE. So look out for difference of two squares wherever you see it.
You did, but you
So
saw
it's only
it.
like x squared minus
It says to circle.
You all okay with that?
No, this one.
Oh, that one.
Right,
Only
here we
I
are.
couldn't be bothered. Well, I'm
Right.
confused.
First non-GCSE topic, so this is limiting sequences. So what we're looking for here is, can we cancel down? We're just interested in the highest powers, because they're both linear, it's actually quite a straightforward one. That 4, as n goes to infinity, becomes virtually nothing. It's ridiculous. You know, n was a billion, 3 billion plus 4, who cares about the plus 4? It's the 3 billion that's the biggest, the thing that dominates here. So really, what you need to do is kind of go, I can ignore that. Oops. Ah! Now what have I done? Right, so I can ignore that 4. So it just becomes 3n over n, which is just 3. So on a harder level, what they might ask is something like this. I'm going to just quickly scribble one on the side here. Let's say you had something like 6n squared plus 2n minus 4, and on the bottom you have 3n squared minus 4n plus 2.
No, I'm gonna.
So, video okay? You can see it?
Yeah.
What's this number called?
This is n terms of sequence, limiting values for sequence.
You need a bigger booster than that.
So, as n tends to infinity, as n gets really, really large, well, 2n is going to get really large, but nothing compared to 6n squared. The 6n squared is going to dominate. Similarly, on the bottom, the 3n squared is going to dominate. So with this kind of situation, you just basically ignore everything apart from the highest powers. So you're going to ignore that minus 4, you're going to ignore that 2n, you're going to ignore that minus 4n, you're going to ignore that 2. Because when n becomes huge, they are nothing compared to these two, and those two dominate. So it just becomes 6n squared over 3n squared, which is just 2. Yeah? So with this n tends to infinity kind of question, you basically just get rid of everything apart from the highest powers that cancel out. Okay. Right. That one should be okay, isn't it? Just rearrange, get the gradient to show their parallel. So make sure you have a little sentence in there that says the gradient of this one is 3. Well, when you rearrange that, are you going to get y equals 3x plus 4? And when you rearrange that one, divide through by 3, you get y equals, divide through by 6 even, 3x minus, and it doesn't matter, you can just write that as 5 over 6. And then you go, oh, gradient of 3, so they are parallel. Have a sentence in there though. Don't just leave it like that. Have a sentence in there, just say, same gradient, so they're parallel. All good? Moving on. We're going to cancel mode, aren't we? And then we do this. Well, I've got this now. I've got this. No, now I've got that. Okay. Differentiating. So, what you need to do when you differentiate, hopefully we can all remember, you take one off the power and times by the old power down the front. It's got to be single terms. So if you've got it in a fraction, that's no good to you. We're going to need to do some dividing through to get it into single terms. Also, I would really suggest writing things as powers of x, even if it's a negative power of x. So with this thing here, we're going to separate this out into 2 bits. That goes straight away right, no it's not. I'm getting the hang of this, obviously. So, no. Yeah. Right. So, I'm going to split this into 2 separate fractions. I'll go longhand to start with. Many of you would skip this step, and that would be perfectly fine. I would skip it as well, but just in case you don't really realise what's going on there. So see how I've separated that out into 2 separate fractions. Yeah, because it's that divided by x to the 4 and that divided by x to the 4. Now I can simplify. Well, 4x cubed over x to the 4, isn't that going to just be 4x to the minus 1? Yeah, x cubed divided by x to the 4, subtract the powers. Then, this one's easier, just x cubed. Now we can differentiate. So, differentiating, minus 1 comes down the front, so it's going to be minus 4x to the minus 2. X cubed comes down the front, the 3 comes down the front, so it's 3x squared. Ooh. Not rocket science, that one. Go on.
In like the test, are there going to be am I different wording for asking divide?
Yeah.
Like,
So,
sometimes I don't know which.
so it says it could be differentiate. They might have wording. Rate of change. They might use, if it's f of x, if they say f of x equals 4x cubed plus 7, whatever, yeah, then they might ask for f dash of x. F dash of x means do over the x. They also might talk about the rate of change. The rate of change means differentiate, but that would be with t's because it's usually the rate is to do with time. So they might talk about the rate of change. So you wouldn't have an x there, you might have a t instead. And that means, oh, I've got to differentiate. Rate of change is all about, so you know like speed is technically the rate of change of distance with time. How the distance you're going changes with each second. So speed is rate of change of distance of time, so rate of change is all to do with time. Okay? So there might be a question where it's like, the distance is this related to time. An object is moving through the air, and with this formula, the distance it is away from the origin is t cubed plus whatever. And they say, find the rate of change, or they might even say find the speed, and you have to realise, if I'm after the speed, it's rate of change, I do ds by dt. So I differentiate. Okay?
Yes.
Right, yeah. So, next. What have we got here? Equation of circle, that's not too bad.
Is this a normal one?
AB is a diameter, work out the equation of the circle. No, because this
Yeah,
is not a circle that is in around the origin.
We can't.
I don't think.
Yeah.
Yes, it is.
Yeah.
It's actually at the origin. Yes, it's going to be the origin. Yeah.
Yeah, I
So,
was doing it all yesterday.
thinking about.
It was like x minus something squared.
So, thinking about this. Thank you. There we go. So, if A and B are two. If that's a diameter, obviously the midpoint is going to give us the centre of the circle, and the midpoint of AB is 0, 0. Add the two coordinates together and divide by 2, so minus 12 plus 12 is 0. Divided by 2 is 0. 1 and minus 1 added together, 0. Divided by 2 is 0. Okay, I'll do a different one if you want in a minute. And then, if you know the midpoint 0, what you now need to do is go, right, I need the radius. Because do you remember that every circle will have this equation? X minus a squared plus y minus b squared. This is on your formula sheet actually, isn't it? It's on the insert.
Is it?
Yeah.
I was asking Mr. Hood about this yesterday.
I put the formula sheet on my teams for year set 1. I don't know whether set 2 is there.
We don't deserve the nice things. Did he?
Well, he went extra step.
Oh.
Yeah. So this is your general equation for any circle. Any circle. A and B are the centre. R is the radius. So if our midpoint wasn't 0, 0, we'd have x minus the coordinates of the centre of the circle. Right, to find the radius, well, don't we just find the diameter and half it?
Yeah.
Or, alternative, because we know it's 0, 0 there, we can just find what that length is. It's up to you, what you want to do.
I think that one.
That one? Okay. So, this is the point down here, let's do this one. 12 minus 1. And this we know is the point 0, 0. If you think about a right angle triangle, it's gone from 0 to 12, so that's 12. And it's gone from 0 to minus 1, so that's a drop of 1. A little bit of Pythagoras. And we're going to get 12 squared plus 1 squared equals our radius squared.
I can't see.
Yeah? From 0 to there. We could have done from there to there and then just halved it at the end. You then get r squared equals 145.
Yeah.
And you don't need to square root it because the equation of a circle has r squared on the end. So your equation is actually going to be x squared plus y squared equals 145. Don't need to square root it because r squared is the last part of your circle equation. Now, obviously that bit would change if our midpoint was something different from 0, 0. If it was 2, 3, it would be x minus 2 squared plus y minus 3 squared equals 145. Any questions yet?
And you know on that, what's the A and B?
The centre.
Okay.
Centre of the circle.
Thank you.
So that's why when, now a 0, 0, 1 is GCSE. When it's not 0, 0, that's when it becomes further maths.
Wait, what? I printed out a maths book though,
Mm-hmm.
and it had one that wasn't in the centre. Like it wasn't 0, 0.
It probably wasn't right out the equation though. 1.
It was. Wait, I've got it in my book. Val, give me a moment.
Alright for me to clear this while. Right, what's next? After sort out. Matrix.
Wait, is that it? Yeah. That could be alright.
Oh yeah, where'd you get this from?
Look at the front, it's like only doing 9 questions.
That's further maths.
Oh, I trust them though. I
Right.
trust Pixie Marks.
Is it an Excel?
Right,
Yeah.
this next one here. So you've got matrix representative transformation. Now, it's not really that important, this particular one, because it tells you the image appears at minus 8, 7. You've got to work out x, y. So this point x, y has gone through this matrix and has then come out as minus 8, 7. So what that means is we've taken the matrix, keep forgetting to do the pen. Right, so we take the matrix 4, 0, minus 2, 3. We put the point through it, and the point is x, y. And it gives us minus 8, 7. Now, there are clever ways of doing this with an inverse matrix, but you haven't done inverse matrices, that's A level. But, so,
I don't want to
don't worry, and it's not difficult, but anyway.
I'm sure.
Anyway, you don't have to use the inverse matrix. There is a slightly longer way, which means we just multiply that out. And then actually it's quite easy, because do you remember you do 4 naught against xy gives you minus 8. So the 4 matches against the x, the 0 matches against the y. Do you remember how to multiply out matrix? Remember doing this, basically? So 4 times x is 4x, and I'm going to write this, 0 times y is 0y. Even obviously that would be pointless, but I'm just going to write just to emphasise how that would work out. And that gives us minus 8. So we do that row against that column. We keep going when we multiply matrices. We do that row against every column, but there's only one column, so we stop there, and we move to the next row, and do the next row against column. So it would be minus 2x plus 3y equals 7. Yeah?
Yeah.
Is everybody? So, everybody okay with matrix multiplication? Row against column, row against column, row against column. You keep going until you've got no more columns, then you go to the next row. So, do you want me to just quickly remind you of the matrix multiplication, which is a bit harder than this?
Yes, please. Yeah.
So if you were doing something like 1, 3, minus 1, 2, and you were multiplying it by this matrix, 4, 7, and instead of just like a simple column vector, it was another 2 by 2, minus 2, 1. Your first answer would be that row against that column. So 1 against 4, 3 against 7. So that's 4 and 21, 25. But you can keep going. That row also against that column. So 1 against minus 2 and 3 against 1 gives us 1. Now we've run out of columns, so we move down to the next row against. So the answers, that row in the answer, that row in the answer is that row in the question, if you like. Then minus 1, 2 against that will give us 10. Minus 1 against 4 and 2 against 7. And minus 1, 2 against that gives us 4. And there's our answer. we now run out of columns to do, we've got no more rows to do. But you would carry on. If you had more rows, you would just keep carrying it on. Yeah? That's how you do matrix multiplication. Right, with this one, don't we get x is minus 2 from that? And if x is minus 2, in there for, isn't y 1? You can solve that, can't you? We're all clever people. Right. Let's move on. Solved by factorising. So, it's a cubic, but it's not a nasty one. It's one we can do. Because, isn't there x in every term? Do not divide by x. Factorise the x out. Because if you divide by x, you're going to lose a solution. You get the others, but...
Oh yeah, factor it, yeah.
So, I'm going to take that x out.
What did you going to do that?
So it's left me with 2x squared minus 9x minus 5.
We're not copying it, it's just factor.
Yeah.
It's normal now.
No, not this one. Okay, so, happy with that?
Yes.
We then factorise that. Has anybody done it already?
We're gonna
Yeah.
Go on. 2x.
2x plus 1, x minus 5.
Oh, look at that. Nice and easy. Yeah? And so you end up with 3 answers on this one. You get your x equals minus a half. You get your x is 5. But you also get x being 0 itself. This x being 0 would work as well. All good?
Yeah.
Okay.
Sorry, can I see you?
It's quite a generalisation. I think we could probably leave this one as is normal maths. Work out the length AG. Well, AG, from there to there, isn't that just a diagonal? So you could do the quick way, which is just 3 squared plus 4 squared plus 12 squared square rooted. Did you know you could do that?
No.
Okay, okay, maybe I will do this then.
How do we just do Pythagoras?
Yeah.
Yeah, I do.
Yeah.
Did you do Pythagoras twice?
Yeah, but by doing Pythagoras twice, you end up just doing 3 squared plus 4 squared plus 12 squared square rooted.
Wow, life out.
Let me show you. So, if I want this line across here,
Triangle days.
that is a really straight line. Never mind. So I know that dotted line there is 12. If I went across to here, to get my right angle there, it's tough to draw with this. Are we happy that, okay, if I want to find AG, I now need to know what EG is. And I've got a bit of Pythagoras just to find out what EG is. Right angle there, shall I? So wouldn't EG squared be equal to 4 squared plus 3 squared? Yeah? Agreed?
Yeah.
Yeah? Right angle on the bottom, that's 4, that's 3. Okay. Now I'm not going to work that out, even though we all know it's.
5 squared.
I'm not going to work that out because now, to get AG squared, wouldn't I have to do 12 squared plus EG squared? Agreed? Well, isn't EG squared 3 squared plus 4 squared? So actually, don't I end up just doing that, that and that all squared and added together and then square rooted to get what AG is? We're convinced now.
I don't think I'd think of the series on.
But you've now seen it.
You might remember. Potentially. Wait, so if it's just like, is it only with a cuboid?
Yeah. However, even if you forget, just do double Pythagoras. You get there, wouldn't you? For 3 nice marks. All good?
Yeah.
Be happy if I move on?
Yeah, that's what I'm thinking. You're going to put some out in.
Right. What's next?
A graph.
Nice. Okay.
I've not seen anything like that.
So this. Okay. So this is what's known as a piecewise function, in that it's 2 functions cobbled together, put together. So you've got one function, which is a nice linear graph, minus half x plus 21. And that's only valid between 0 and 2. So you can see between 0 and 2, we can tell straight away that p is at 2. Yeah? We just got the straight line graph bit. That line is minus half x plus 21. Then, at 2, it turns into a quadratic, ax squared plus bx. And you can see that looks like a quadratic. And we know between 2 and 6, so you can see q ends at 6, okay, is this quadratic graph. Alright, happy with that? Okay, so, if we know ax squared plus bx is the equation of this quadratic, well, we know what point this quadratic goes to. It goes to 6, 12. So if I put x is 6 in there, I know it's equal to 12, don't I? So that's okay. So straight away I can say that 12 is equal to a times 6 squared, so 36a, plus 6b. So I've got an equation in a and b. Everybody happy where that equation's come from? Just put in 612 into there. Agreed? But I do know another point. The other point I know is p. And I know p has an x-coordinate of 2. Yeah? So, if I put 2 in there, don't I get 4a plus 2b? But to work out what it's worth, I need to know its y-coordinate. But the y-coordinate there is the same as the y-coordinate on the straight line at that point. So if I put p equals 2 into here, I'm going to get my y-coordinate. So minus a half times 2 is minus 1, plus 20, so that's 20. So that's actually at 20. That's meant to look like 20. That is still failing. Right, ignore that. So we're going to have 20 there. And then simultaneous equations.
Wait, what's the second equation?
20 equals 4a plus 2b. So we put 2, we now know that point is 220, don't we?
Yeah.
So put x is 2 in there, and it's got to equal 20.
Oh, because it's part of the same line.
Yeah,
so
it's part of the quadratic, and it's part of the straight line.
Oh, no, I see. Yeah, thank you.
Okay. Now, it's a bit of an unusual piecewise question. They may ask you to sketch them sometimes, and you just have to realise, okay, so between 0 and 2 I have to sketch that straight line. And then between 2 and 6 I then cobbled it together with that. But that's what piecewise is. Okay? Ooh, okay. Can I go next?
I know, I have to like sort of.
Okay, so.
Did we do this?
Yeah.
When?
I don't remember. Just like I was doing practice questions the other day, and I was like, wait, flips.
Practically.
No, division by
Yeah.
algebraic.
I showed you what's known as the spot method.
Yeah.
Piecewise
Oh, even though we're different classes. We've never done that. I'm
Right.
right now.
So,
Miss Hope said you
If-
didn't have to do it.
if you are.
Silence.
Lost the class.
It's like you've got us.
Right. If you are revising this, they might show you a technique called algebraic division. And so I will show you that quickly, just in case they come up with a question where they force you to do algebraic division. I do a different method. Which is much easier.
Can we do that instead?
Yeah, I'll do both.
Okay.
So, this is the method you might see in revision guides and stuff like this. So, if we know 3x minus 7 is a factor of that, that means it goes exactly into that. So we divided 3x minus 7 into that. Now how we do that, long way, is this. Just like your normal long division, 3x cubed minus 4x squared minus 13x plus 14, and we're dividing it by 3x minus 7. Okay? Now, this is how long division works algebraically. It's kind of the same principles. You see how many times that goes into that, what have you got left over, and you kind of continue it on. Yeah? Can I do a numerical one alongside it so you can kind of see what's happening? Yeah?
Does that have to be 3x cubed?
Yes, it is. Thank you. Sorry. Right, so let me do a numerical one so you can see what's going on. Well, let's do something simple, like 7 into something large. 7,504. 7,504. Can I change that?
I did. I thought it was just binomials.
Actually, no. Let's make that 8,900. Just because it'll make it easier to see what's going on. Okay, so do you remember when you do long division, you go, oh, 7 into 8 go 1. And then you see what remainder.
Yeah.
Now, when you're doing your remainder, technically what you're doing is, oh, 7 times 1 is 7, and I've got 8, so I've got 1 remainder that I'm going to put onto there. Okay? And you would just put the little 1 up there, wouldn't you? But if you remember, possibly, you might have been taught to do this, 7 times 1 is 7, then I take my remainder, and I've got 1, and then I bring my 9 down, that kind of... Yeah, you've got that left now. Yeah? You ever seen that kind of thing? It's a much longer way of doing it. And then you go 7s into 19, well that goes 2. And 7 times 2 is 14. So I've now got 5 left over, and I've still got the 100, yeah? So it's a very much longer way. You normally just put them up there and make it really quick and easy. And then you go, oh, 7s into 50 go 7, and 7 7s are 49. So I've got 1 remainder, and then 7s into 4 go 2, yeah? Now, how this works with this? Well, you've got more than one term. So what you do is you take the big term, the main term, the 3x, the highest power, basically, and you go 3x into 3x cubed. X squared, because 3x times x squared makes 3x cubed. So it goes in x squared times. So that's your first step. You go that into that. Okay? Now, just like I did, 7s into 8 go once, and then I did 7 times 1 and subtracted, I'm going to do the same. X squared times this is 3x cubed, and then minus 7x squared. Yeah? That times that is 3x cubed minus 7x squared. Now I'm going to subtract to find what remainder I've got. Nothing. Minus 4 minus minus 7. Doesn't that make 3x squared? Bring this down. So say that one more time. So I just take the main power, 3x, and I see how many times it goes into 3x cubed. So I've got to think, what times 3x makes 3x cubed? Oh, x squared. I then do that times that, just like I did 7 times 1, and then subtracted. So that times that is 3x cubed minus 7x squared, and then subtracted. Bring everything else down. I then just repeat that process. So I'm going to do 3x into 3x squared. Doesn't that just go x? And x times 3x minus 7 is 3x squared minus 7x. I'm then going to subtract nothing. Minus 6x? That's 14.
No, this is a hard one.
This is the hard one.
Oh, is that an easy one?
One that I prefer, yeah.
No, but if they
Just
force
in
you
case
into
for
this,
whatever reason,
force
you know,
you
unless they,
into it.
if they put one of those questions up where it's like, you know, Brendan is doing long division and this is his working,
Brendan?
where has he gone wrong kind of thing. Right, and you're right, he doesn't go wrong, he never makes mistakes. Then you go 3x into minus 6x goes
2 minus 2.
minus 2, yes. And minus 2 times 3x minus 7 is, oh my word, minus 6x plus 14.
Crazy.
Oh, no remainder. Oh, it goes exactly.
Oh,
Hooray.
right.
That's why it's a factor.
Oh, wow.
Okay.
You're not looking at that, okay.
So, in this long method, we now know that it's 3x minus 7 times x squared plus x minus 2 that makes this thing. Okay, so we would then, I need to leave myself a bit of space over here. We would then go, so, okay, so it's 3x minus 7 and 3x cubed, 3x, sorry.
Wait, what are we looking at now?
I'm just, right. So it's 3x minus 7 times x squared plus x minus 2. So that factorises into that. I've found how many times that goes into that, so that's my factors. I can then factorise this, 3x minus 7, and that's going to be x plus 2x minus 1.
It's coming back.
X squared plus x minus 2.
I remember
All good?
the last
Yes.
part only though.
Yeah.
This is fine.
Okay, so just in case, that's algebraic long division.
Wait, what do you give as the answer, sorry? 'Cause it
That. Because it says work out the other two linear factors, they're x plus 2 and x minus 1.
okay. Thank
So
you.
you'd write x plus 2, x minus 1. Okay. Here's the quicker way. This is, I call it the spot method, but I think it's sometimes called by inspection. So, the way to do it is this. You go, right, I've got this horrible cubic, no not horrible, lovely cubic, and I know that 3x minus 7 is a factor. So doesn't that mean that that cubic is 3x minus 7 times something?
Oh, we've done this. You know that.
Yeah, this is what I taught you.
Oh, no, my God. Get told.
Oh, right. I forget because,
I just mean it all along that inspect section. Yeah.
She's just so loud.
yeah, I haven't done this with any of you, right? No. Right, so, okay.
No.
So, the spot method works like this. You go, right, okay, well, if 3x minus 7 times something makes that, I know two terms straight away. I know, surely, that's got to be x squared. Because only 3x times x squared will give you the 3x cubed at the end start. Equally, because I've got 14 there and minus 7 there, what's going to have to be on the end?
Minus 2.
Minus 2, because minus 2 times minus 7 will make a plus 14. And that's the only way the plus 14 comes from. That number times that number. So, that only gives me one little term to find. And you can do it in a couple of ways here. We could either concentrate on the x squareds, or we can concentrate on the x's. I'm probably going to go x squareds first. Minus 4x squared. I've got to make minus 4x squared. At the moment, with my, if I multiplied this out, I would get a minus x squared by doing, the x squared term by doing minus 7 times x squared. So that would give me minus 7x squared, wouldn't it? So if I've got to make minus 4x squared, and at the moment I'm getting a minus 7x squared, what other term am I going to have to get to minus 4x squared?
Plus
3x squared.
Yeah, I'm going to have plus 3x squared. Well, how do I get plus 3x squared? Isn't that from the 3x times the missing term?
Oh my gosh.
And
This is a
3x
good
times
method.
1x, isn't it? Will make the 3x squared. And you're at to that stage and then you finish it off.
That's so easy.
Yeah, that's
Yeah,
what you
this is insane. But you need to be ready for the other one unless they force you.
Is this factor doing that?
Yes, and there's a part B that's actually a factor theorem, where I can actually do the factor theorem now on this. Right, can I
This is the spot by inspection
yeah,
process.
can I click the cross now? Have you okay with that? Right, I think we'll do this 11B and then we'll stop for lunch if that's okay.
Is this not near the whole course?
It's getting there. Are
Okay.
you disappearing up here?
Oh no.
I'll record it anyway.
Wait, why is it
Here,
I'm just hoping by
I think I'm going to like,
where's the record? I could put it on YouTube.
yes! Hey YouTube!
Is YouTube better?
Yeah, trigonometry and stuff.
Send it on the chat
Oh, you do that instead.
YouTube's better!
Okay.
Come have a vote, come have a vote.
I'd watch it on YouTube.
I'll put it on my YouTube channel.
What's your YouTube channel?
Trigonometry Sunday. Calculus.
Triggering calculus and stuff.
So,
So, next.
bro, I'm famous.
There's a lot of videos on my YouTube channel that's just A-level maths, so I wouldn't look at those.
So if you want to get ahead for next year.
but I'm not doing
And then maybe further maths A-level as well, so anyway, but anyway.
Yes, go on.
Right, so, next bit. This is the actual genuine factor theorem itself. So, you remember that what we did, we ended up with 3 brackets. We ended up with we got our cubic and we got 3 brackets. I forgot even what they are. What were they? 3x minus 7, x plus 2 and x minus 1, is that right?
Yeah.
Okay, so that's our f of x, yeah? Our function comes out of that. If all 3 of these are factors of the expression, now, so that means if I multiply that all out, I get back to the original expression. So the factor theorem works like this. If I took x as 1, wouldn't that make that bracket 0? And so would the whole thing be 0?
Yeah.
So if I went back to the original cubic and stuck 1 into it, I'm going to end up with 0. Okay? Equally, if I put minus 2 in, won't that give me 0?
Yeah.
And 7 over 3 will give me 0. So basically, any of these, if I pick the x value that makes it 0, when I put it into the original cubic, it's going to give me 0. So, yeah, if I put 2, x minus 2 I know is a factor, into there, it should give me 0. Well, it won't because I've got a's in there, but I know it's got to equal 0. So I put x equals 2 into my expression. So 2 to the power of 4 is 16, so 16a. 2 to the power of 3 is 8, times the 3 is minus 24a. And then I'm going to have 10 and minus 22. So all I've done is put 2 into that expression. And I know if that is a factor of that, that means when I put 2 in, that whole thing should be worth 0. And so now I can just work that out. Minus 8a minus 12 equals 0. So doesn't a equal 3 over 2?
Is it minus 3 over 2?
Doesn't a equal minus 3 over 2?
Guys.
As I said, I never make mistakes.
It's
Okay, how's that?
cool.
So fun.
That's part one.
What? On the answer?
No, that's part one of today.
Oh,
Oh, shoot.
I see.
Yeah. So, if you stop the recording,